Hi class, this is Professor Smith. I'll be doing a movie on hypothesis test for the difference of population means t-test. When you're taking the exam, the final exam coming up, you won't have the title for the topics. And I wanted to point out ways that you can determine, well, which type of problem is this? Is it a difference of means paired comparisons? Is it a difference of means z-test? Is it a difference of means t-test? And it turns out there is some information in the problem that will alert us to let us know which ones or which tests we should use. Let's go ahead and start with this example. A psychologist wants to test whether there is any difference in puzzle solving abilities between boys and girls. Independent samples of 9 boys and 7 girls were chosen at random. The boys took a mean of 30 minutes to solve a certain puzzle with a standard deviation of 4.4, and the girls took a mean of 33 minutes to solve the same puzzle and a standard deviation of 5.3. Assume that the two populations of completion times are normally distributed and the variances are equal. Can we conclude at the .01 level of significance that the mean puzzle times for boys, mu1 differs from the mean puzzle times for girls? So let's open up math type so we can capture the information that I would be writing down if I was using paper and pencil. In the first sentence, it mentioned that there were, well, actually the second sentence, that there were independent samples of 9 boys and 7 girls. So we know that we're going to have 2 categories, or 2 groups, the boys and the girls. And the fact that they're furls, how about that? And the fact that they say a random sample of 9 and 7 respectively lets you know that's N. And again, because there's 2 different groups, we want to denote which one's the sample size for boys compared to girls, so we use N1 and N2. So we have N1 for the boys is 9, and N2 for the girls will be 7. We also have that the mean is 30 with a standard deviation of 4.4 for the boys and 33 and 5.3 respectively for the girls. So let's capture that in math type. We also notice in the problem that it says assume that the two populations of completion times are normally distributed and the population variances are equal. So if they say that the population variances are equal, but they don't give you the values of those variances, that means the variances for the population is unknown. That's our clue that it is going to be a hypothesis test between 2 means t test, like student t distribution. And if you were to use a TI-84 to answer the question, it would be a 2 sample t test. And you would say yes for a pooled sample, for the pooled standard variance. I didn't say that right. I think I should go to bed. I think I'm too tired to do this problem. And you would say yes for the sample variances are pooled. They ask at the .01 level of significance if the puzzle times for the boys differs from the girls. So that would be mu1 being different than mu2. And we also have the claim that is the claim, and that the claim means that they're different. So we're going to go through the 5 steps of hypothesis testing. So the first step is we're going to write the null and alternative. Because we see the not equals, we know that that's going to be the alternative. And the opposite of being not equal is equal, which would be the null. And we also know in the problem it states that perform a two-tailed test. So I'm going to, instead of writing that in math type just for expedience, I'm going to put it here. So we're going to have mu1 equal to mu2 and mu1 different from mu2. Because the sample variances are unknown yet equal, we're going to use t, and the degrees of freedom is going to equal the sum of the sample sizes less 2. So we have the sample size of 9 and 7, which is 16, and if you take away 2, that'll give you 14. In our case, then we got 9 plus 7 minus 2, which was 14. The next thing we're going to do is the test statistic. And if we pull up our Chapter 11 formula sheet, we'll have the following. Instructor resources icon. So there's a resource icon, so you would grab it from there. Make this a little bit bigger so you can see. Perfect. All right, so when you click on that icon, you'll be able to have access to that PDF. And also, once I finish this movie will be located as well as a video. All right, so we have difference of 2 means t, and you'll notice here it says the population standard deviation sigma 1 and sigma 2 are unknown, but the variances are equal. All right, so the first thing we're going to do is find this pooled sample variance, and it's given by the following formula. It's equal to N1 minus 1 quantity times the sample variance for the first population squared plus N2 minus 1 S2 squared all over the value of the degrees of freedom, the sample size for the first, sample size for the second, less 2. All right, so let's go ahead and compute S of P squared and then go ahead and compute the test statistic. So S of P squared is we're going to take our first sample size, which was N1, which was, or in our case, it was 9 boys and 7 girls. So it's going to be 8. So it's okay with you if I don't put 9 minus 1 in parentheses. It'll just save us some writing. And then we also had that S1 was equal to 4.4 squared. And the standard deviation for the girls was 5.3. All over the degrees of freedom, which we got was 16. Yeah, 9 plus 7 minus 2. So there we have it. 14, I typed 16. And if you add 8 plus 6, you'll also get 14. All right, so that'll give us the pooled sample variance. So let's see, find that value, and that gives us 23.101. And I'm going to hit the store button, and as soon as I hit the store button, an M shows up, letting me know that that value is stored. So if I cleared it, and if I did 2 times 8, 28, I'm sorry, times 3, and did that computation, if I hit recall, it'll still bring that number up. All right, so that is the pooled sample variance. Now we can go ahead and substitute into the formula. So the formula for finding the t-test statistic is going to be x1 bar minus x2 bar. And so x1 bar was 30 and x2 bar was 33. So it's 30 minus 33, all divided by the square root of the pooled sample variance. So I'm going to hit recall. If you want, you can truncate some of those some of those digits if you don't want so much to be captured, but Alex will take either answer, whether you abbreviate it or not. All right, so then once we have that S of P squared, then it's just 1 over the first sample size, so 1 divided by 9 plus 1 divided by 7. And remember, that was the sample sizes for the 9 boys and 7 girls. Notice that the square root is expanding along with the expression, so make sure that the square root captures all of it, that it doesn't accidentally creep outside of the square root. So that's the formula for finding the pooled sample variance. And so we get a test statistic of negative 1.239. In this problem, they're asking us to find the 2 critical values. at the 0.01 level of significance. So we're going to take that 0.01 and split it between two sides, because with a two-tails test, there's two ways that you could be different. You could either be to the left of negative 1.239, or you could be to the right of positive 1.239. So we're going to take 0.01 divided by 2, and that's going to give us 0.05. And then we're going to do t, and then the degrees of freedom, which we've already computed, was 14. So that's going to give us our right number, 2.97, 2.977. And then to find the left one, we just take the opposite. I'll open up Word and draw the pictures so that we can help make the decision on if we should reject H0 or do not reject H0. So I've opened up Word. The T distribution is much like the Z in that it's bell-shaped, but it's a family of curves. So this is the one that I've hypothetically drawn for degrees of freedom of equal to 14. So if you had degrees of freedom equal to 12, it might be a little bit different curve, still bell-shaped, but the shape of the curve or the standard deviation might be different. All right, so let's go ahead and draw our cutoff value. So my critical region is anything to the right of 2.977 and anything to the left of negative 2.977. Then we take our test statistic, and our test statistic was negative 1.239. I always like to draw a circle around my test statistic and then draw an arrow to where I would place it on our scale for our t distribution. So negative 1.29 would definitely be to the left of 0, which would be in the middle, but not far enough over to be in our rejection region up to the left of negative 2.17. And so therefore, since it's not in the critical region, then our decision is going to be to do not reject H0, not in favor of H1. And therefore, since H1 was the claim was that they were different, we're not in favor of the claim. And so if we're not in favor of the claim, that means that we are saying they are different. We're saying no to the claim. So it turns out, I don't know what happened, but my recording video lost the work that I had done, but we did check it and it did work. And what I'd like to do is do a second video showing you how you can do this same problem using a TI-84 for those of you that happen to have a TI-84. So I hope this short movie was helpful. For those of you that have a TI-84, I'm going to show you how you can do the same problem using the TI-84. With the critical value approach, it'll do everything for you except give you the critical values, but you can find the critical values using the ALEKS calculator. So I've got the calculator turned on. To the left is what this calculator screen looks like, but if you want to see it a little better, look to the right. So we're going to go ahead and select Stat. When we select Stat, we're going to scroll over using the arrow cursor key and go to Test. So you're always going to use Test whenever you have a hypothesis test or a confidence interval. Ours is a 2-sample t-test, which is item number 4. So I can cursor down to 4, or I can type the number 4 on the keyboard. And then it'll open up 2-sample t-tests. And then it will ask us, do we want to put in the data or the statistics? Since statistics is blinking, that's highlighted. And so I've entered in the data already. We had the mean for the first sample for the boys was 30, the standard deviation 4.4, the sample size was 9, the mean for the young girls were 33, and for the standard deviation of 5.3, and the sample size was 2. And then what you have to do is you cursor down. Right now it's defaulting to not equal to, but let's say that it was on the greater, less than. So mu1 less than mu2. Whatever's blinking is what's highlighted, so I would need to hit the cursor and then hit enter to change it to not equal to. It's pooled sample variance, so if it were blinking on no, I would cursor over to yes and then hit enter. And then you scroll down to the color, and you pick any color you want. And then we're going to select draw. You can hit calculate, which is faster, but I like to show draw because it shows the p-value. So I'll hit enter, and now it's going to draw the curve and show what's the probability that we would get that test statistic. So when you're using the TI-84, step 1, finding the null and alternative, that's the same. Step 2, determining it's the t distribution because we know that the variances are equal even though they're unknown. Step 3 is that test statistic. So this is where you can use the calculator to get the test statistic. And you'll see here it's t equal to negative 1.238, and I think we wrote it in as negative 1.239. So, and it also gives you the p-value. And what happens is that test statistic of negative 1.238, it wasn't extreme enough to be in the critical value zone. And if you move that test statistic, in other words, if the values were different from our sample, as that test statistic slides over, guess what happens to that area under the curve? It gets smaller. And then it gets so small that it's less than the alpha level, hence extreme, hence in the critical value, hence we reject the null, because how could we get something so extreme if the null were true? So that's why when the p-value is less than or equal to alpha, we reject H naught. All right, so I just wanted to show you that way, or how to use the TI-84 in order to do these problems for those of you that might have the calculator, and you can use it for the final exam. All righty.